It's not uncommon to find scrap Amiga boards on eBay. That's where this one came from. Obviously from an Amiga 500, and it looks like it's been pillaged in the past because there's a few bits missing. Agnes, Denise and one of the CIAs have been removed, along with 3 of the ports, RGB, parallel and the external disk drive. What sets this one apart though is that this board is somewhat rare, because this is a REV3, one of the very early Amiga 500s. Why would anyone scrap a board like this? So my guess is that this board has been lying in someone's parts bin for quite a while, because yeah, it's got those various bits removed, but it's also got a fair bit of damage. These capacitors, for example, they are definitely broken off their leads. A couple of the other ones have had bad knocks as well. That one, for example, looks like it's been squashed. There's some damage on the tops of these RAM ICs and the CPU. There's a transistor there from which one of the legs has snapped off. Not only that though, because unfortunately whoever removed the ports, well, when they were removing the RGB port, it looks like they've been a little bit heavy-handed. We're missing a few pads and there's a few traces ripped up. A couple of nasty looking scratches on the back of this as well. So the plan for this video is to try and get this running again. So first order of business is let's try and deal with the damage. It is going to need a recap. I think I'll just start with that. Now normally these boards don't really need it. The capacitors on them are usually fine. I'm just doing it here because of the damage. In fact, I don't even think that one's soldered. No, it's not. Look at that, that just lifted out. But yeah, I'm only doing it because of the damage to the various caps on here. May as well just replace them all. The board is from 87-88 according to that sticker. And yeah, that lines up with most of the date codes on most of these ICs. 87, 87, 87, although that's CIA, that is from 1990. So perhaps that one has been replaced in the past. But we're going to start with that recap. I'm going to replace all of these with the Worth electronic capacitors. These things, the nice red ones, I know they're not everybody's cup of tea, but they are a good quality capacitor and they're red. They look cool. Let's do all the 47s first of all. 47 microfarad, just like that one. And as per typical with an Amiga 500 board, the large ground and VCC planes are putting up a bit of a fight. So I'll need to attack it from 2 angles using both the desoldering station and the soldering iron. Is that one clear? And that's that one. We'll come back to that transistor there, which is kind of wrecked. The clock generation on this board is obviously different from the later revisions. The later ones would use a crystal oscillator, and in fact it looks like there's a footprint for one such chip there, but this one is just using a crystal. Looks like there's a trim cap here for adjusting it. So these old caps, Nichicon branded, 47 microfarad, 16 volt. I'm replacing them with these ones, as I said. Same capacitance, but this one is 25 volt. Right, one down. Plenty left to do. those are the caps that I have with the same, you know, capacitance as what came out of there. 3300 UF. These are 35 volt though. The original ones were just 10. These are way too big. So I'll have to order a couple. Otherwise though, that is the recap complete. While we're waiting on these, let's though turn our attention to some of that damage. Things are very nasty here around that RGB port, but I also want to take a closer look over all of these scrapes and scratches here, particularly that bit. I want to take a look at that with the microscope. And so this is one of the main areas where the board is scratched up, but to be honest with you, it just looks like superficial damage to the solder mask. The copper underneath, it does actually look okay. That joint there, I think might be cracked. I'll just put a little bit of flux on that point that we want to reflow. Helps if I actually put it on the correct point. Then just a quick touch with the iron, reflow it. And that should now be fine. Or in fact, that probably was okay actually. I thought that was a pin coming up through that or something. It's not, it's just a via. So the solder might have just cracked in it slightly, but I'm sure the via itself was okay. That's one of the caps that we replaced there. Just notice that, just at that position. Between there and there. And I must have lost a pad around that and didn't notice. It's that cap there on this side. But you can see the trace only runs to it on this side. It's that point up in there, the positive side, and it all looks okay up here, so it'll be fine. Solder has flowed through onto that pad nicely there when we fitted the cap. One of the other areas of damage then on the bottom side is just here beside the expansion slot, and again it mostly just looks superficial, although just there's a little nick in the copper. Let me see if I can get in a wee bit closer to that. And apologies for the shaky cam. Unfortunately the microscope moves a little bit every time I touch the desk. But yeah, I'm not sure about that. That looks like a crack across that PCB. What I'll maybe do at this position is we'll just scratch off some of that solder mask back up there and just flow a lot of solder over all that. There's actually like a lip in the copper at this point as well, just there. It's almost as if the board's been scraped and it's cut part of the copper off. That bit there looks similarly damaged, but I dare say that'll be okay. I'll maybe just go over that whole area actually, just with a fiberglass pen. Just expose a bit of that and flow a lot of solder into it. A few other scrapes and scratches in this area as well, but that all just looks superficial. The worst of the damage, I suppose, is actually at the ports, and in particular the RGB port, because look at the state of that. Absolute carnage. We are missing pads all over the place. In fact, we're missing 4 pads there. I dare say that is one of them. A lot more damage down this end. Pad missing there. That one has been turned upside down. It's just about to fall off actually by the looks of it. I think I'll just help it along its way there. Gonna be repairing all this with wire just. That one still seems okay. And that one looks like it's been broken off there, twisted around and soldered onto that. I dare say that port was removed with excessive heat. Someone just removed that in a hurry, maybe even with hot air, because the board is discolored just here. Slightly lighter color there compared to just beside it. And it hasn't quite delaminated, but I think that's a symptom of the board being overheated. Thankfully, they took their time a bit more with the other ports. That one's the parallel port, and it all looks okay. And then over here at the disk drive port, there's a little bit of damage there to some of the through-hole plating, just there for example. But I think it'll be alright. So some repair work required then. We need to make good around the RGB port, and I want to rub down this area here, just where those traces looked a bit dodgy. The other various bits and pieces where there are scratches, such as say that bit where we looked at originally. I'm just going to put a bit of solder mask over that just to protect the bare copper. So one thing we didn't look at there, which we probably should have, is these couple of factory bodges on this board, or I assume they're factory bodges anyway. So this wire, that is coming from pin 18 on the video hybrid and run across via components here to pin 10, I think, on the RGB port. It's coming through that resistor and that ferrite bead, I think, running to pin 10. Now if we take a look at the schematics for the later revision board, these schematics being for the REV3. So we can see that on pin 10 of the RGB port, that is composite sync. Now it does look as if they're doing things slightly differently here, rather than taking it off pin 18 on the video hybrid like they have on this board. They are instead on the later board going back to U41. Now U41 is fitted, there it is there, and they're making it selectable through a jumper block JP11, which I don't think is on this board. No, I don't see it there, but on the REV3 they're going through that jumper block down here through a resistor and taking it off pin 12 on U41. Now on the REV3 the composite sync signal is coming in to pins 8 and 9 on U41. That is a 74LS245, no sorry, beg your pardon, 74HC245 bus transceiver. Signals coming into pins 8 and 9, so back out again on pins 11 and 12. Pin 11 going to pin 18 of the hybrid. Pin 12 on the REV3 is going to the RGB port. So yeah, all they've done is pick it up from pin 18 on there, taking it to the RGB port. I would bet if we measured that resistor there, that will be 47 ohms. And yeah, that's pretty much exactly what it is. And have I just spotted damage on the top side? What is that? I thought that was a hair or something. That isn't. That is a trace. So we will have to do a bit of repair work up here too. It's coming from that via there and should have ran up here, presumably to that point. In fact, is that another one? Oh no. Yeah, someone was very heavy-handed when they were removing that port. They have ripped that trace off right back down to here. It looks like it came up here through that text and possibly to that point. Where does that one go back to? Comes back to that via there. So it may be a case of cutting that off and then running a patch wire on the bottom side. I want to try and keep the top of this looking as original as possible and rather not be running patch wires on the top side. The other modifications on the bottom then, you can see that this large trace here, this has been cut away just at that point. Now we can follow it back this way and it's connecting there through the coil to the 5-volt supply rail. So that is VCC running along there. But instead they've cut that, made a bridge here. And I think what they're doing there is that they are filtering the 5-volt supply to the video section. And we can see that on the schematics again, on that same page, actually just in this section. So I think that's what they're doing there. They are separating out VCC from the video supply rail. And indeed, actually, if we look at it on PCB Explorer, there is the video section. There is that video supply rail. Now granted that's on a REV8 A500 Plus, but I think that's what they're doing there, possibly through that component, which is that resistor there. And in fact, if you look back on PCB Explorer, it's that resistor R406. That sits in that position. It is linking the VCC rail with the Vid Plus rail. Now, okay, it does say there VXX Plus, but if we go back down to here, it goes through that filter there and that's where VCC is ultimately picked up. If I'm right, that should make that resistor 4.7 ohm. And okay, no, it is smaller on this one. It's 1.4, but I think that's doing the same job. And I'm just noticing there, actually, there's another bodge associated with that sync line just there. That trace has been cut. Wonder where that goes back to. What would have came from that point, which I think is that via there, and has a trace running down to pin 20 of the video encoder. And that bodge, actually, what that's doing, if we look back at the schematic, see the way they're taking composite sync from U41 through JP11. Well, the other option on JP11, if you were to close positions 2 and 3 on it, is to take the sync from pin 20. Not really sure what the difference is there in the sync signals. If anyone maybe knows, maybe let me know down in the video's comments. The other bodge wire then, this one, going between Agnes and the CPU, it is carrying address line A19, and that's certainly that pin on the CPU anyway. I can only assume that they missed that trace. There is a trace coming from it there to the expansion slot, and on the other side there is a trace that makes its way up here and across the board to Gary, but I can't find any going to Agnes, so that's what that is doing. But I think that's enough waffling on my part, so it's time to do some repairs. Do need to get the 3 ports. I'm just going to pull them off another scrap board that I have. It is very much a scrap board beyond repair. Unlike this one, I'm pretty confident that we can get this up and running. So time to crack on and do a bit of work. I'm going to try and tackle this first. So as I said, just with the fiberglass pen, although I can't find the fiberglass pen, so I've only got the refills for it. Probably cut the hands of myself doing this, but we'll go gentle at it. Just want to try and expose some of this copper and flow a bit of solder onto it. And you know what, I think I'm just going to do the same at this area as well. Okay, a bit of flux and a bit of solder. Just go over it then with a bit of braid, just to mop up any excess. And then we'll just tidy it up. And I'll give it another quick look, just on the magnification, especially just at this point here. Because after we've coated it with the solder, it will be easier to see if the copper is broken. Granted, I could test it with a multimeter as well, I suppose. And yeah, I don't actually think I need any magnification there. I can see that okay. Those traces all look fine. Yeah, they are all okay. Can't say the same for this mess. Okay, I've tidied all this up as best I can anyway. And on the top side here, we have 3 traces to repair. Those 2 that are lifted, there and there. And there's a pad missing at this point, which just runs from that filter there. So for these 2 traces that have been ripped up, I'm just going to hold them at the last point. They are on the board there, and we'll just cut them off. This one actually goes the whole way back to that via. Now, like I said, I'm going to run the patch wires on the bottom side, just to keep the top as clean as we can. So the first thing we're going to do is fit the RGB port. It's then just a matter of running all these patch wires. Now, the ones from the top of the board. So I need to come from that via on the bottom side to the first pin on the bottom row of the RGB port. And we're just going to patch it using the usual black solid core wire. Just something like that. Obviously, I'll try and run the wire as neatly as we can. And I think that'll do it. Okay, excuse the mess of flux, but those 3 black wires there, they are patching the 3 missing traces on the top side. Quite a few to patch on the bottom side though. 1, 2, 3, 4, possibly a 5th one there. I'm not sure if that's making connection or not. Let's just test it with the meter going from there to there. Yeah, no, that's okay. So with 4 to patch down here. Now, because the traces here are pretty good, it's just the pads that are actually missing. What I'm going to try and do is just scrape off a bit of the solder mass just on the trace, just to expose the copper. Then we'll get a bit of flux on it, bit of solder. I have stripped the wire quite long, like that on purpose. We'll load up a bit of solder onto the tip of the iron. And let's see if I can get that connected there first of all. Yep. I'm just going to take it and go round the pin. And we're going to have to quickly try and flow solder onto this so as to not disconnect that joint we just made a second ago. Yeah, I think that's good. And that's that one fixed. Okay, I think that's it. Let's just check it here quickly. Got the multimeter in continuity, so from there to there. Yeah, that's alright. From that pin then to there, I think. And yeah, that's okay. And from that pin to there. Yep, that's good. And then from that pin to there. That's good as well. So I think that's all the repairs we need to do. I'm going to tidy that up and we'll get to those other 2 ports on. And then we'll have a think about testing it. Got the other ports fitted, and you can see that I got fed up waiting for the 2 smaller capacitors to arrive, so I fitted the 2 comically large ones there in the meantime. Did have to bend the video hybrid out of the way to make them fit, but it'll do for now, it'll do for testing. There is one other thing that we need to fix though before we test, and that is this transistor. It's a 2N5770 NPN transistor. Fast switching transistor, I believe, which would make sense, wouldn't it, because it's involved in this clock circuit. That leg of it there though has snapped off. It's obviously got quite a bad knock. You can see the scrapes on the top of the CPU there. So we will unfortunately have to replace it. Now, I unfortunately don't have any of those in stock, but I'm going to try and use another NPN transistor. 2N3904, similar sort of characteristics, so I hope it works. I have ordered a couple of these, so if it doesn't, we'll just have to wait, but fingers crossed, it will work. Now granted, it is a recovered part. I actually pulled it off the same A500 board that those other ports came out of. Was serving another purpose on that other board though. But as I say, hopefully it works in there. Just while I'm on the bottom side here, just let me show you. There's a new solder mask, just where we exposed the copper earlier and dragged a bit of solder over it. That has all been protected again. Okay, before we go throwing any power at this though, I want to do a quick test to see if anything is shorted. Now I'm just going to test it at the coil here. I'm looking at that from right to left. The rightmost pin is ground. Yep. Next one in is 5 volt. And we're getting just over 100 ohms there. I think that's normal for an Amiga 500. Next one then is negative 12. Nothing there. Last one is positive 12 and nothing there. What about between the voltage rails? Between negative 12 and positive 12, that's alright. Between positive 12 and 5 volt, that's okay. Between 5 volt and negative 12, that's okay as well. The other thing we're going to need then is a couple of extra chips. We're missing Agnes, Denise, and another CIA. I do have them here. And now granted, there's absolutely nothing to say that the other chips on here work, although I've never seen a bad 68,000. Pretty sure the ROMs are fairly hardy, so long as you don't, put it in upside down or something. Don't think I've ever seen a bad Paula, but certainly Gary and CIAs, they can go bad. And as we've seen earlier, it does appear that that CIA has been changed. It's got a far later date code. That one is 1990. All the other chips on this are 87. There are a couple of bits of logic though dated 88, which ties in with this. So Denise will go in there. And I am just sticking with OCS Denise. I just want to try and keep this as original as we possibly can. The other CIA will go in there. And Agnes in the theme of keeping it original, I have just went for the 8371. Agnes goes in there. That was a bit loose. I normally go in with a, snap. That just sort of fell in there. So possible weak spot, but that is everything. Is it going to work? What do you think? I personally think it won't work because, why else? Why else would somebody have started to strip it? These boards, or certainly the later boards, the REV3 for example, they are pretty much bulletproof. Not so sure about the REV3, but other than a couple of minor differences, they're more or less the same thing. So let's see what happens. Okay, here we go. 3, 2, 1. We're getting a signal and just a black screen. That's okay. Let's check voltage levels. 5 volt is looking good. Negative 12 is fine. Positive 12 is fine. Let's check it on one of the logic chips. Yeah, that's alright. Yeah. Pretty sure that voltages are stable. So, nothing happening. A little bit of heat in Agnes. The rest of... Ooh, that CIA is really warm. That's the one I just bought and put in there. Don't tell me that's bad. But that is quite hot compared to everything else. Black screen, usual culprits. CPU, that could be connectivity issue with Gary or Agnes perhaps. Let me just try the brains of the operation first. I'll use this nice ceramic one that I have. I mean, I probably should be checking clock and reset, shouldn't I? If this doesn't do anything, that's what we'll do next. CPU swapped, power on. Video signal again, but black screen. So let's check the other two things that we need. We know we've got voltage, let's go for clock and reset. Just look at them on the 68,000. Clock is on pin 15. Reset is on 18. So let's see. 3, 4. Well, I know that it's not running. Those first 4 pins there, they are part of the data bus. In fact, the first 5 pins are. And that is all just low. So system is definitely not doing anything. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15, yeah, okay. We have got a clock. So that's alright. But 16, 17, 18. That is high, which would make you think that's okay because reset is active low. But just let me power cycle the machine. And yep, that is working perfectly. So what is going on? Is there any activity at all on the data bus there when we first powered up? Nope. Doesn't seem to be. What about on the address bus side of things? We just check any one of them up here. Hey. And the address bus is just floating. Oh well, no, not all of it. Those pins up there are, that is 5, 6 and 7, address lines 5, 6 and 7. I think the easiest thing to do first of all would be to test the chipset. I'll pull out one of my REV3 boards and we should just be able to drop all of that straight in there and see what it does. Okay, my REV3 A500, just check it still works okay. And yeah, that's fine, comes up straight away, no issues. So, I'm going to pull the whole chipset out and we'll stick all of this in and see what happens. This machine is slightly modified, as you can see. It's got an IDE 68K and got to go fast RAM card sandwiched together there. Modified Kickstart 1.3 with SCSI.device so we can boot that, and an RGB to HDMI. Not using the HDMI though at the minute, just using RGB itself. And no, we have a black screen. Okay, so must be something wrong on the chipset. I'm going to hope it is one of the chips that came with it rather than one of the chips that I bought. So CPU, ROM, Paula or Gary. I would put my money on Gary. Does that fix it? No. So I'll go back to this Gary from the REV3. And let's try the other chip. Let's try Paula. Yeah, still doesn't work. So we'll go back to that one. I don't think it'll be the CPU. I'm sure we changed the CPU out on the other board to one which I know definitely works. So, must be the ROM. Nope, it's not that. So that only leaves one other possibility in that CIA chip before we need to start thinking if one of the other customs that I bought, if one of them's bad. So is it this CIA chip? No. So it's one of the chips I bought, is it? That CIA chip there, that one that I bought, remember I said it's getting hot, it's getting really hot on this board as well. Don't be bad, come on, it cost me money. So I'll put that one there which came out of the REV3 originally. And away it goes. So it looks like the CIA chip which I bought to populate a missing chip on the REV3 board, it's bad. Oh well. Let me move all of this over to the REV3 board and we'll try it again. Well, let's test it then. Unfortunately, this damned thing slipped and put a scar on Agnes. Somebody needs to redesign this PLCC extraction tool, or I just need to get a better one. These things are hateful. But it's all back in there now, and if this works, that more or less means that this board was partly stripped for no reason. Yep, there it goes. Looking good. We'll pause for a minute because there's no floppy drive. 1.3. Yeah, this board seems to work fine. Let's hook up the floppy drive. I'll hook up a keyboard as well and we'll try Amiga Test Kit. Right, I'll just have to hold it like this But our power LED comes up. Machine boots, Amiga Test Kit. And there we are, 68,000 PAL OCS memory. Half a meg of chip. That's all we've got on the motherboard there. Let's just test it. Yeah, that's fine. Been round 5 times there, no issues. Keyboard seems to be working, but let's just test all the keys to make sure the controller's working. Yeah, it's all fine. Controller ports I'll come back to. Don't need to test the floppy drive, that drive's okay. Audio. They're not plugged in. And yeah, that seems to be fine. Four channels are all working. Low pass filter. Seems to be working because of the way the power LED is turning off and on there. But let me change to that. So low pass filter is on, we can't hear anything. And I still can't hear that. I'm not sure that's working right. Video. All looks pretty good. Yep. CIA on chipset. Oh, we've got a CIA failure. Let's try it again. Yeah, CIAB. Which one's that? Is that one? Although it otherwise doesn't seem to be affecting the operation of the machine. Real-time clock, we don't have one of those. We can test serial and parallel. Just let me grab the dongles. So parallel port is in there. Serial port is this one. Voltages are all correct because the LEDs are there. Let's do a serial loopback test. That's good. Parallel test. That's good. Plug in the mouse here quickly just to test the ports. That's working fine. We'll just test the joystick port with the mouse as well. Yeah, that is all good. So potential CIA issue still, although it doesn't seem to be affecting the machine otherwise. I'm not sure how that might manifest a problem, you know, in running software or whatever, but let me just grab a CIA from my other machine. Assume, of course, that that is CIAB. Is it even CIA? I would assume that's B. F7, F1. And yeah, that is all now okay. So there must be a minor fault in that CIA. Looks like I need to get a pair of them to have this REV3 sitting perfect. Well, one REV3 board fully operational. Turns out there was nothing wrong with it other than the damage that someone caused when they partially stripped it. So why would anyone have done that to what is possibly one of the more rare Amiga 500 boards? Just because something's rare though doesn't necessarily mean it's sought after. These boards are renowned for being not as stable as the later revisions. And in terms of that low pass filter thing, well, that's actually missing from this board. Or should I say the ability to turn it off is missing from this board. On the later revision boards, such as the REV3 here, that's where the ports came from for this one. You can see I previously stripped the RAM off this. This normally lives on my wall and it's just used for parts. But in the audio section, there are 2 FETs and a transistor. They are missing from this board, and it is those which switches the audio filter. And you can see it here on the schematics. The FETs are at positions Q321 and 331. When a voltage is applied to the gate of that, it allows the audio signal to pass between the drain and the source, essentially bypassing the low pass filter, which is the 2 10k resistors and the 6800 picofarad cap. Voltage is switched to the gates of the 2 FETs by transistor Q301, which in itself is controlled by whether the LED is on or off. LED off, transistor 301 supplies power to the gates of Q321 and 331, bypassing the low pass filter. So yeah, that's why we weren't hearing any difference turning it off or on in Amiga Test Kit. This board just does not have that feature. But what are we gonna do with this? I could just get a case, stick it in that with floppy drive and keyboard and call it a day. I'm not 100% sure that I want to do that though, because I do have 2 other fully assembled working Amiga 500s. Do I really need a 3rd one? I'm not so sure. Given what this is though, I am sort of tempted to make it some sort of display piece. So I would be keen to hear your thoughts on that. What should we do with this REV3? Those 2 caps still haven't arrived. Whenever they get here, I'll swap them out to something that looks a bit more sensible. But other than that, all that's left for me to say is thank you very much for watching. If you enjoyed it, I would appreciate a thumbs up, and please consider subscribing because it really does help the channel. I do want to try and grow the channel for the remainder of this year, so if you like what you see, please hit that subscribe button and the bell notifications. I know you're probably sick of people asking that on YouTube, but it genuinely does help. Helps get these videos out there. But that's it. Thanks for watching, and I'll see you next time.